I'm Addie,
I'm Lauren.
and we're going to be comparing the stream quality between Connelly's Run and the Tributary to Mill Creek.
This is for our environmental toxicology class with Dr. Lau. What is environmental toxicology and why should we care? Studying and understanding environmental toxicology is important for recognizing pollutants and toxins that are harming our freshwater ecosystem. There is a complex interconnection between biological components, water chemistry, and physical habitat of freshwater ecosystems, but understanding how they play a role with the health and integrity provides in-depth insight to our freshwater streams or rivers. There are many components to consider for figuring out the toxicology, but in general, it's important to focus on assessing stream health. You can do this by taking in the aspects of freshwater streams and rivers, which include water chemistry, physical habitats, location, macroinvertebrate assemblage, and more. In 1969, the beginning of the Clean Water Act took place due to damaging events caused by a fire on a freshwater river in Ohio. High quantities of chemical waste were discovered, and soon after this, all freshwater streams and rivers needed to be tested to ensure they weren't experiencing similar water chemistry and habitat destruction. The goal of the Clean Water Act was to create clear guidelines to keep freshwater pollutants to a minimum and prevent habitat destruction. Freshwater ecosystems provide not only resources for animals, but for humans too, like drinking water and recreational use. Our team had a goal of following the CWA and testing parts of Connelly's Run and the Tributary to Mill Creek to see what their toxicology was like and what we can do to improve the streams.
Our team had the purpose of using a stream monitoring program to identify any disturbances in Connelly's Run and the Tributary to Mill Creek and identify how they might be responding to those disturbances. We decided to choose a monitoring program that assessed the actual impact from the disturbances. When studying impact control, the Tributary to Mill Creek was the control and Connelly's Run was the impact. Due to that, Connelly's Run has much more human interaction and recreation. When studying, the unit used fluvial hierarchy from the monitoring program. It provides numbers of small streams and large rivers. The streams form hierarchies that are nested, starting with the smallest permanently flowing stream. The stream order measures the size of the stream and relates to several other measurements, which include the areas drained, the volume of water discharged, and the channel dimensions. And that's referring to the picture on the right, just for some background information. Most river systems are made up of low-order headwater systems with short length and small drainage areas. Every stream drainage area is similar in size, which is the drainage basin. This type of view of river systems also shows the processes at upper levels in the hierarchy control what happens to lower hierarchy streams, but not the other way around. The types of disturbances include pulses, which are short-term events, presses, which are long-term events with constant intensity, and ramps, which is long-term events that change intensity over time. When identifying the type of disturbances we might have, this will allow us to understand any alterations with the stream health, physical conditions, and ecological states of freshwater ecosystems. Our team strongly believes that disturbances associated with Connelly's Run is a ramp disturbance due to the constant recreation that varies throughout the season. We used rapid habitat assessment to discover any alterations between Connelly's Run and the Tributary to Mill Creek, which will show us if something might be impaired within the interconnection between health and integrity of the streams.
So we have assessment methods and results. So for our quantitative methods, we have channel measurements, riparian area measurements, and a lot more. So for channel measurements, there's a sampling reach length, and this was determined by dividing our sample reach distance by 10 and adding that value to each transect. For Connelly's Run, the length was 277 meters, whereas the Tributary to Mill Creek had a length of 80 meters. For establishing transects, there were 11 transects that were established to measure the left and right bank canopy cover and cross-sectional depth profile. Connelly's Run's transects were set every 27.7 meters, and the Mill Creek, the tributary to Mill Creek's depth and channel unit classifications were recorded every 8 meters. When determining the thalweg distances, we measured maximum depth, classified habitat, determined presence of small sediment at 10 to 15 equally spaced intervals between each of 11 channel cross-sections. We measured wetted width at 11 channel cross-sections and midway between cross-sections, which were 21 measurements. For the riparian area measurements for riparian cover, this was determined by using a densiometer to measure riparian cover. We taped a V on a mirrored surface and used 17 of the possible 37 line intersections to help determine the riparian cover. For Connelly's Run, we had a 14% riparian cover, and for the tributary to Mill Creek, we had a 15% riparian cover. When looking at riparian land use, there's 3 main ones, which are glide, pool, and riffle, and then there's an other section which is anything that's not those 3. So for glide, that is water that is moving slowly with a smooth surface. For pool, that's still water with a glassy surface. And for riffle, that's water movement with small riffles and waves. So the next section is Woolman pebble count, and that is looking at the median pebble size in millimeters and percent fines, and this was calculated from the Woolman pebble count. The size of 100 pebbles were measured using a gravelometer. Then we measured velocity. This was measured using the bobber method. We measured the time the bobber traveled 5 times. Connelly's Run was measured 9.7 meters, and tributary to Mill Creek was measured 7.5 meters. We then calculated discharge by multiplying the area by velocity. The discharge is the volume of water moving over a rough stream bed over time. Then we looked at the benthic macroinvertebrates. These were collected in one prior to conducting the physical habitat assessment. This is important because identifying where macroinvertebrates are in the stream and how many there are and what kinds there are can show us the bigger picture on the stream health. To do this, we used a specific kick net. The samples were preserved in 90% ethanol, and the macroinvertebrates were identified to their family in the lab. And then looking at physical habitat, this was measured in longitudinal, vertical, and lateral dimensions of our stream reaches. The water depth was measured, and the channel units were classified at equidistant spots along the thalweg profile from the beginning to the end of the stream reach. Connelly's Run depth and channel unit classifications were recorded every 2.77 meters. The Mill Creek tributary depth and channel unit classifications were recorded every 1 meter because the mean wetted width was less than 2.5 meters. So looking at more quantitative methods, we have water chemistry and microclimate, which is presented in the graphs to the bottom right. For the water chemistry, this was measured using a yellow spring instrument, which included water temperature, pH, dissolved oxygen, conductivity, total dissolved solids, salinity, and nitrate. When looking at microclimate, this data was collected using a Kestrel 550 environmental meter, which included wind direction, wind speed, wind crosswind, headwind, chill, dry temperature, wet bulb temperature, heat index, dew point, barometric pressure, altitude, and density altitude. When looking at the qualitative methods, we had a physical habitat survey, and for this we used EPA guidelines to do a rapid habitat assessment. Habitat and biological diversity is closely related to the health of the rivers and streams, so we used physical characterizations for this section that tested things like general land use, descriptions of the stream, description of the riparian vegetation, and much more.
The last thing we looked at were the reasons for impairment. The metric scoring procedure compares each monitored site to a single reference site, and those are used to determine the water quality rating for the monitored sites in one of 4 categories. which would be non-impaired, slightly impaired, moderately impaired, and severely impaired. Ratings based on monitoring are used in several state programs, including Clean Water Act and the 305B report. For Connelly's run, the VSCI score was 55.1 according to the guidelines, making it impaired. The tributary to Mill Creek had a VSCI score of 55.9, also making it impaired. Both streams were only minorly impaired. They can be addressed through mitigation, through preservation of the streams, which offsets or compensates for expected adverse impacts to similar nearby ecosystems. And lastly, we would like to thank Pathways for Radford for being stewards of Wildwood Park. Thank you to Mayor Horton and the City of Radford for access to Connelly's Run and allowing us to conduct our stream assessment. We would like to thank the landowners for access to Tributary to Mill Creek and allowing us to conduct our stream assessment. But most importantly, we would like to thank Dr. Lau for giving us the guidance that we needed. Without this support, we would not have received the results and information that we did.
Now we have our literature cited for all the information that we put on the PowerPoint. And now it's time for questions and answers.